There's a question that keeps resurfacing in technical discussions around Bitcoin. When can quantum computers break its cryptography? It's usually dismissed quickly. Too theoretical, too far away, something for future protocol upgrades, and for a long time, that dismissal was reasonable. Because for years, the data told a very comforting story. To break modern public key cryptography using quantum algorithms, the required hardware was so large that it simply wasn't practical. In 2012, estimates suggested that running Shor's algorithm against RSA 2048 would require around 1 billion physical qubits. At the time, quantum computers had roughly 5. The gap was enormous, so enormous that the risk felt safely hypothetical. But while the conversation stalled, the reality underneath it kept changing. Most people assume quantum risk is only about hardware. How many qubits exist today? How fast companies are building bigger machines? That's only half the picture. The other half is how many qubits are actually required to break cryptography in the first place. And that number has been dropping fast. Not because Bitcoin weakened, not because cryptography failed, but because researchers kept finding more efficient ways to run the attack. Better circuit designs, improved error correction models, more realistic assumptions about physical systems. The math didn't change, our efficiency did. And the result was dramatic. That original estimate of 1 billion physical qubits didn't slowly decline. It collapsed. Today's best estimates put the requirement at under 1 million physical qubits and still trending downward. That's a 1,000-fold reduction in roughly a decade, driven almost entirely by algorithmic and theoretical progress. At the same time, quantum hardware kept scaling, from 5 qubits to dozens, to hundreds, to more than 1,000 today. And when you place those two trends side by side, something becomes hard to ignore. One curve is falling rapidly, the other is rising steadily. Neither trend alone is alarming. Together, they change the timeline. Some company roadmaps now openly discuss million-qubit systems around 2030. Roadmaps aren't guarantees. They slip, they miss targets. But trends don't need to be perfect to matter. If hardware continues scaling and cryptographic requirements continue dropping, the crossover point doesn't sit in the distant future anymore. It moves into the late 2020s, possibly sooner.